Good day, guys. Welcome back to the King's Regulars. Just on Wednesday, which was 2 days ago, I sent forth a question, to the general public that I need a solution to it. Fortunately for me, a day after, which was yesterday, you know, solution was provided to the question, and the wonderful thing is that it was from one of my colleagues. Now, this colleague of mine, was such that we attended the same university, and we usually call her boss lady. So she just said she wanted to take her mind back, to the university days, and she tried it out and got the answer to the question. You know, at the end of the whole thing, looking at it, I noticed that the solution was correct, and I also noticed a mistake, in my own solution. Now, after that, she tried another method and got the same answer. So, in a short while, I'll be showing you the two solutions, to the question that I asked of help, or I asked of help of. So, sit back and look at the solutions of the question. Okay, starting with the first solution. In my last class I said, when you want to solve a question like this, we have to substitute P for this, is such that since P is not in this equation, what you first do is to either transform the equation to this form or transform this, to a form where you can substitute y, inside. Now, how do we go about it? Since P is equals to y minus 1 over y, in this case, then I would say, making, y solve the formula, how do we go about it? In this case, the L center becomes P equals to what? Y squared minus 1 all over what? Y. So y here now is the what? Is the LCM. So cross multiply, I would have what? P y squared equals to what? Equals to, py equals to what? Y squared minus 1. And at this point, leaving y squared at the left, I have py plus 1 all equals to what? Y squared. So let's leave this as a particular equation. Now, it means whenever I see y squared, in this case, I'll substitute what? Py plus 1. Now let's solve. Now, reducing this equation, how do I go about it? The first method is to say, let's group this, let's group this. So I have y to the power 4 minus 2y to the power 3, then minus, okay, so minus 2 into what? Y squared minus y plus 1 all equals to 0. So you know that if minus 2 comes out, this remains y squared. This replaces this as what? Minus. And then I have y remaining here. At this point, let's now factorize y raised to power 3 from here. What have we left? Y raised to power 2 from here. What have we left it? Y squared into what? Y raised to power 2 minus 2y. Then minus 2 into y raised to power 2 minus y plus 1 all equals to 0. Now, remember, y squared equals to what? Py plus 1 at this case. So let's substitute. So at this point, I have py plus 1 into what? This alone is what? Py plus 1, then minus what? 2y, then minus 2 into py plus 1, alright, minus y plus 1 equals to 0. So y squared is py plus 1, py plus 1. What remains? Minus 2y minus 2, py plus 1 minus y plus 1 equals to what? 0. Expanding. Let's expand as quick as possible. So I'm going to use this to expand all this, then use this to expand all this. The same thing goes here. So I have what? P squared y squared, then plus what? Py, alright, minus py times this is what? 2py squared. Then using 1 to expand, plus py plus 1 minus 2y. And expanding this now, I have what? Minus 2py minus 2 plus 2y, then plus 1 all equals to 0. Now at this point, let's check to know which are like terms and which are not like terms. So I have this like term here. So I have p squared y squared plus 2py. Does this have a brother? No. Minus 2py squared. Does this have a brother? Yes. 1 minus 2. Okay, minus 1 plus that's 0. That's gone. So minus 2y plus 2y. That's gone. What remains? Okay, minus 2py. Minus 2py all equals to 0. Alright? So what happened? I cancelled this and I cancelled this. Right? So at this point I have what? P squared, y squared. I believe this also cancel out. What remains? Minus 2py squared all equals to 0. From here, let's factorize. So y squared comes out. What remains? P squared minus 2p all equals to 0. Since I want to solve with p, since I'm solving with p basically, let's divide the two by what? Y squared. What remains? I have p squared minus 2p equals to 0. So that is p into what? P minus 2 all equals to 0. You can solve it quadratically. So at this point, I can say p equals to 0 or p minus 2 equals to 0, which implies that what? My p is equals to 0 or p equals to what? 2. Because when minus 2 comes to the right, it becomes what? Positive. Now at this point, what do I then do? Since I've got my p now, let me now get my y. So you see, when p equals to 0, what happens? Come back to this equation. Recall, p is equals to what? Y minus 1 y. Alright? So when p is equals to 0, what happens? I have 0 equals to y minus 1 over what? Y. Cross multiply. Multiply by y, the LCM. So that's 0 equals to y squared minus 1. So it means that what? 1 equals to what? Y squared. This implies that what? My y equals to the square root of what? 1. So the square root of 1 will give me what? Plus or minus what? 1. Then that's my first two values of y. Then when p equals to 2, substituting there again, I have what? 2 equals to y minus 1 over what? Y. At this point, multiply all through by the LCM, which is y. What do I have? 2y equals to y squared minus 1. So at this point, what do I have? Bring this to the right. I have y squared minus 2y minus 1 equals to 0. Now, we solve this with completing the square method. What you should have is what? Or formula method. What you should have is what? Y to be equals to 1 plus or minus the square root of 2. So when you solve this with formula method or completing the square method, you should have what? Y equals to what? 1 plus or minus the square root of 2. Now that's the first method of solution. Now in my next video, I'll show you the next method of solution.